Welcome to section 3.4, solving systems of equation and three variables. So, I talk about, and when we're working in three variables, in this case, x, y, and z, we're going to have three equations. So, our first goal in working with this type of example is that we get equations with two variables. So that way we can employ the same methods that we did in 3.1 to solve for one of the variables and then solve for the second. So let's take a look at these equations here. First, I'm going to label my equation. So this will be equation 1 or E1, equation 2 or E sub 2, and then equation 3, E sub 3. Now the reason I wrote that is because I'm going to write little lines of labels so that I know what I'm doing. So when we're solving these type of problems, it's best to have your work organized so that you don't get lost. Then it's easy to backtrack so that way you don't waste time starting over. Alright, so with this example, we got equation 1, equation 2, and equation 3. What I want to do is make a new equation, which is 4, by doing a combination of one of two of these equations out of 3. So now this is not a one-way method. There's multiple ways of solving this, but what I want to do is eliminate x. So you can eliminate y or you can eliminate z, but in this example we're going to focus on eliminating x. Alright, so what I'm going to do is, for elimination of x, let's talk about equation 1 and equation 2. Now when we're picking our equation, I'm going to pick one equation where I'm going to multiply by a coefficient because we're going to employ the elimination method. So when we're doing 3x3s, 3 equation 3 variables, it's always best to do elimination method. That's the easiest way. You can still do substitution, but it would be a lot more work. Elimination would be best. Now again, you can do a substitution, it works that way. But in this method, in this problem, I'm going to be using the elimination method. So I'm going to pick equation 1 where I'm going to be multiplying by coefficient because here's why. Equation 1 and equation 2, the x's can cancel out. I just have to multiply by one of them by -1. And then equation 1 and 3, the x's can cancel out if I multiply the first equation by -2. So again, I want to eliminate x. So I'm going to first focus on equation 1 and equation 2. So for equation 1, since I want these x's to cancel out, what I'm going to do is I'm going to multiply equation 1 by -1. And then combine it with equation 2. So again, all I'm doing is multiplying -1 to equation 1 and then combining it with equation 2. So I'm going to write that I'm multiplying by -1 to equation 1, which is x minus y plus 3z equal 5. Doing that, I'm going to get -x minus plus y minus 3z equal -5. Alright, and then my equation 2 will simply stays the same. X plus y minus 4z equal -10. Since I'm not multiplying by anything, I'm just going to bring it over here. So it's going to be x plus y minus 4z equal to -10. So now I'm combining these two equations. So let's take a look. Notice how we're working with the same variables, it's opposite sign and same number, invisible 1, invisible 1. So these x's will cancel out. I'm going to combine the y's. Positive 1y plus 1y will be 2y, negative 3z minus 4z, that would be negative 7z, equal negative 5 minus 10 will be negative 15. So my equation 4 will be 2y minus 7z equal negative 15. So I use equation 1, I multiply by negative 1, and combine with equation 2 in order to eliminate the x's. And then I got an equation with two variables, in this case y and z. We're going to do the same process for, again, our fifth equation.